Let us deal with few more sums from calorimetry, exercise 11b. Okay, so let us see sum number 12. 2 kg of ice melts when water at 100 degrees Celsius is poured in a hole drilled in a block of ice. So there is a hole and it is drilled in a block of ice. Okay, and there you are pouring 100 degrees Celsius water, and that block of ice is 2 kg. Okay, so how much water you are adding? What mass of water was used to melt that? So that is the question, and specific heat capacity is given, specific latent heat is also given. So let us see how to do it. So that means water is changing from 100 degrees Celsius to water at 0 degrees Celsius, and this ice is also melting and from 0 degrees Celsius, and it is becoming water at 0 degrees Celsius. So heat absorbed by ice is equals to heat evolved by water. How much ice? You can see that there is no change in temperature, so it is heat absorbed will be ml. Okay, and heat evolved here will be mc delta t. So just substitute all the values. Mass is given here 2 kg, and 336 is L value into 10 power 3. We have to find out how much mass of water we are using. So let it be mw into this is the specific heat capacity 4200. You substitute it here, and what is the delta T here? The temperature difference, 100 minus 0. Okay, now multiply these two. This will become 100. So when you multiply these two, and you have to bring this down. So we need mw, right? Mass of water. So it is mw is equals to this thing divided by this. So when you divide it, after that you do cancellation, and then you will find out find it to be 8 divided by 5, which is equal to 1.6. Okay, next sum is sum number 13. Calculate the total amount of heat energy required to convert 100 gram of ice at minus 10 degrees Celsius completely into water. So you are not separately taking water. You're just taking 100 gram of ice, which is at minus 10 degrees Celsius, and you have to change it to water, convert it completely to water at 100 degrees Celsius. So there is a conversion of ice, which is minus 10 degrees Celsius, okay, to ice at 0 degrees Celsius, then from ice 0 degrees Celsius to water 0 degrees Celsius, then from water at 0 degrees Celsius to water at 100 degrees Celsius. So this is the conversion taking place. Clear? So when there is a change in temperature, write mc delta T. When there is no change in temperature, write ml. Okay. And after that, see here, you're not separately mixing ice separate, water separate, and mixing it. It is not like that. So how much ice you have taken, same mass will be of water. Okay, so let us do that. So mc delta T plus ml, you have to add everything, plus mc delta T. Okay, so that m and m will be all mi, that is mass of ice, and mass of water, both will be same. So you can take it out common. So you'll be left with only c and delta T. The c is of ice. Okay, delta T, you can see the temperature difference here, that is 10. Then again m is taken out common, L value is written here. Okay, same way m is taken out common, c, that is of water, is written here, and delta T, you can see the temperature difference is 100 degrees Celsius. So multiply this, write this, multiply this, add up, and then multiply it with this. Your answer is 77700 joules, or 7.77 into 10 power 4 joule. Okay, so this much of heat was totally absorbed while changing it from minus 10 to 100 degrees Celsius. Clear? Question number 14. See question number 14. The amount of heat energy required to convert 1 kg of ice, same thing only, but here heat is given. See, 777,000 joules. So here heat is given to convert 1 kg of ice from minus 10 to 100 degrees Celsius. Here it was actually 100 gram. Here we are taking 1 kg. Clear? and then all the given data, we specific heat capacity of ice is given, heat capacity of water is given, and we have to find out the latent heat of ice. So we have to find out L. Okay, all the things are same, just that here this L we have to keep it as such, L. Okay, so you can see, so ice at -10 changes to 0 degree ice, then water at 0 degree, then water at 100 degrees Celsius. Everything is given. The only thing is here, mass, again it is 1 kg. Clear? So when you take out mass common, you will write it as 1. Keep L as such because we have to find this out value, find the value of L. Substitute the value of Q on the left side. Okay, then add up the values which are given, and then keep L on one side, and then the addition of these two. Okay, you have to add these two and you will get this one, and this value we are just bringing it this side. So I just rearranged it, missed one step, rearranged it, and I have written it like this. That means L is equals to 777000 minus addition of these. So when you add up and you bring it to this side, it will be minus, and you'll get this answer. Okay, next is sum number 15. See, 200 gram of ice at 0 degrees Celsius converts into water at 0 degrees Celsius. So here also you are not taking separately, mixing it, but this ice is only converting to water. Okay, in 1 minute, when the heat is supplied to it at a constant rate, in how much time 200 gram of water at 0 degree will change to 20 degrees Celsius. So there is a change from 0 degree ice to water at 0 degree, and then 0 degree water to 20 degrees Celsius. And we have to find out that how much time it is taking, okay, to convert it from water at 0 degree to water at 20 degrees Celsius. And take specific latent heat of ice to be this one. So we will find that out now. Okay, this is ready. Okay, so we'll first find it out separately here, not like this. We'll find it out separately. So when it changes from 0 degrees Celsius ice to 0 degrees Celsius water, our Q will be ml. Okay, so m is 200 and L is 336. Multiply, you'll get 67200 joules. So this much amount of heat was required, and that too in the question, if you see, it is written that it is, see, 200 gram of ice at 0 degrees Celsius converts to water at 0 degrees Celsius. That means it is the first step here, this step. Okay, this step. And how much time did it take? In 1 minute. Exactly, in 1 minute. So time required is 60 seconds. 1 minute means 60 seconds. So heat required in 60 seconds is this much. So heat required in 1 second will be 67200 divided by 60. Okay, now our next Q is what? MC delta T. Yes, so same, mass will be same, C will be for water, and delta T is 20. So when you multiply it, you will get the Q to be 16800 joules. Okay, so heat required in 1 second is 1120. That means 1120 joule of heat was required in 1 second. Okay, so 16,800. Okay, or 16,800. This much joule energy will be required in how many seconds? That is the question. Okay, so how much time is required? No? So 16,800 joule will be in, same thing, this one, unitary method, 1 second divided by 1120 into 16,800. Okay, then you do the cancellation and the calculation, you will find the answer to be 15 seconds. Clear? So this is how it must be done. These are the sums. You can practice it. Thank you.